Lesson 2. Quantitative Chemistry. To perform chemical calculations, we rely on moles and relative formula mass. For example, the relative formula mass of calcium carbonate is 100, calculated by adding the relative atomic masses of calcium, carbon, and 3 oxygen atoms. To find the number of moles, divide the mass by the relative formula mass. 18 grams of water is exactly 1.0 mole because its relative formula mass is 18. 1 mole of oxygen gas contains Avogadro's constant, which is 6.02 times 10 to the power of 23 molecules. We can also calculate percentage composition by mass. Oxygen and carbon dioxide makes up 72.7% of the mass. When working out an empirical formula from mass percentages, you divide each percentage by its relative atomic mass to find the simplest mole ratio, which gives you the simplest formula like CH2O. In balanced equations, mole ratios let you calculate reacting masses. For instance, burning 0.50 moles of magnesium yields 0.50 moles of magnesium oxide because the reaction ratio is 1:1. You then multiply by the relative formula mass of 40 to find the final mass of 20 grams. You can also calculate gas volumes. Any gas at standard temperature and pressure occupies a molar volume of 22.4 cubic decimeters per mole. If a reaction decomposes 25.0 grams of pure calcium carbonate, it produces 0.25 moles of carbon dioxide, which occupies 5.6 cubic decimeters. Finally, percentage yield compares the actual product gathered to the theoretical maximum. If a student obtains 8.0 grams of product but expected 10.0 grams, the percentage yield is 80%.